This is a notebook which we use to test the dog breed identification with the saved model with on the previous notebook. In this notebook we trained the model, and we saved it into our Google Drive, and we created a new notebook for testing that saved model. So first of all, we connect the over GDrive with this notebook, and we do this with these two lines. So when we run this block, it will ask us to log in into our Gmail, and once we allow the permission in our Gmail, it will automatically connect the G drive with the it will mount to the content and drive. So this is the available. We click on this folder files, and we'll get our drive in under drive, my drive, and everything in that. Okay, so going down, what I did, I randomly picked images like this. So what I done, I created a folder and I called it a test folder. I grabbed random images and I put these images into this folder. Once done, what I did, I created a zip folder. This is a zip folder. I uploaded it into my drive under a folder which I specifically created, dog breed identification folder, and inside this folder that file is uploaded. So once done, I have to unzip the file. So what I do, I simply give a zip file path name and extracted folder path. How we can get the exact path of this? We can simply right click on the folder and we can copy path. So once we done, we will fetch the path here like this. So I just tell it to the test folder zip file path extracted folder path, and with these two lines it will extract all the files and save into that selected images folder. So once done with that, this is a folder for the training dataset, and similarly we can extract the test images. So you don't have to redo this cell. So you don't have to run if you already have these test folder and the selected images folder. The selected images is the dataset which is selected from the actual dataset. We all only grabbed 100 images of each class. So coming down in the extracted folder path, this is the cell which you can run, and once run, it will fetch all the breed names from the folders like this, and from that class folder OS list it will print the class folder and the length of the classes. So these two values are printed. After that, what we are doing, we are simply coming into our main section where we imported bunch of libraries like TensorFlow and Keras for the pre-processing and Matplotlib for plotting the images. We provided our model file name and the actual model, which is MobileNet Model H5, which we saved in our training session. After that, we created a folder and we join the path and we put an path for the test images which we want to predict. So we want to predict that randomly picked images. You can change that images as well. This one is trick. So image size must be 128 by 128. Why is that? Because while training the MobileNet, we implemented the transfer learning with this specific image size. So while the training, we can change that size and the accuracy will go up, but the training time will also arise. So we have to choose this image size accordingly. After coming down the number of images to predict, just ignore that, and we load the model. This one is an important, and where this function comes from this library, from TensorFlow Keras models import load model. So we imported the load model and we can use this function to load our actual model. After that, we have to list all the folders. Well, this one is not done. Okay, so I think this is not the actual case. Okay, so we can simply delete this one. This is an old code, and we can come to the down here. What we're doing is we are importing the extracted folder path. This is the test images. We get all the files, and we fetch only the files with the JPEG and any images we got, and we print that images. So when we run this, what we get is the all the names of the images from the test folder. Coming down, we are ready to display that images, and we are repeating the same step, but here we are counting the total number of images, and we are calculating the number of rows, and we assume that we are printing the images with the 4 columns, and we simply plot that images with the subplot from the pie plot, and we hide empty subplots if we have any, and then we create a layout, and finally we print out total number of images. So here are the total number of images that we have to predict. So these are the images. Coming down, we are repeating the step. We extracted the folder path and the test path and model path. This is the 128 image size, which we do in the training session. 128 by 128. We load the model. After that, we list all the files. Similarly, we done above, and we are iterating through each and every image with this for loop. And each image we pick one by one, then we open the image, then we resize the image by 128 by 128. After that, we are creating a numpy array from that image, and we are dividing by 255. This will uniform the images equally, and after that we are creating npy expand dimension image. It will expand the image into one single vector, and we pass that vector to the model.predict. This will output us the predicted hot encoded class. We have to convert that hot encoded into our actual class index. So we have to find out which class has the maximum probability out of all the classes. So we use np.arg max. It will give the index of the maximum value from that list. Once that we get the class folder, inside the class folder, this is the class folder which we used above here from the training session. These are all the folder names. Basically, these are the classes of the dog breeds. So we are using that list to index our actual prediction. So we'll fetch the class name, which is the predicted dog breed, and we display the image. After that, we on the title put that predicted class is this, which is the actual predicted breed, and then we put the axis off and show the image. So this is how all the images are predicted. Overall accuracy of this training model was 50% almost. So if I take you to the code of the training session, here we have the training session. Let me come down, and where the actual training. So this is the actual training output. So here you can see the training start from 0.1% accuracy and goes to 0.5, which is almost 50% accuracy, 51% accuracy with the loss of 1.6. This could be improved, but it will take more time because we are training on almost 120 classes, so 120 dog breeds, and we trained the model on 10,000 images, so almost 10,000 images, and we iterate only for 10 epochs. We can increase the epochs and we can increase the steps. So that's how it will take overall to improve the model in the next step if we have to. So once we are satisfied with the results of our model, this which is a MobileNet version 2 model, all we can do is we can convert that model to a TFLite model, so we can use it into our Android application for identifying the dog breed. So how we are achieving this? We are loading the model and we are converting with the TF.lite version and the TF-Lite converter from Kira's model, and we are passing the actual model. And we are simply calling the converter.convert. It will automatically convert the model into TF-Lite, and with these two lines we can write that converted model into our Google Drive, which we can see here, and we can download if we have to, and we simply press the download button. It will download that TF-Lite model into our computer, and we simply printed that TF-Lite model has been saved successfully. So that's how we done our dog breed identification. If I have to give you an overview of the transfer learning for the MobileNet, what we done, we created image data generator from our training path, and we created from the train generator, and then here is our base version net model, which we downloaded with the actual weights, and we simply added a new layer, an output layer for the sequential, which is a global average pool 2D model, and ReLU and softmax, and then we compile that model with the categorical cross entropy, and the optimizer is Atom optimizer, which is pretty standard for that, and simply we put a model.fit. So that's the parameter we use to do our MobileNet version 2 deep learning for the dog breed identification. Thank you.